Hi students, in this video we are going to discuss about the long run cost function, and in the last video we discussed about the various determinants of cost and also the cost output relationship in the short run. Okay, and we had seen that the various determinants of cost such as the cost of production, output level, prices of factors of production, productivity of factors of production, technology, etc. And also we had seen the cost output relationship in the short run or cost function in the short run. Okay, and in this video or in this session we will discuss mainly about the long run cost function or the cost output relationship in the long run, and also we will discuss about the optimum firm. Okay, and the cost function in the long run, like in the last two sessions there is a small work for you that you want to comment the definition of long run. Actually this want to comment the definition of the long run. Next we are going to discuss about the various features of the long run. Mainly there are three features. The first one is that there is no fixed cost. In the long run there is no fixed cost because all the inputs are variable, so there is no fixed cost. And we can increase the level of production by expanding the existing plant. It's important. If you want to increase the level of production, you can increase the size of the plant. And if you want to decrease the level of production, you can reduce the size of the plant. Okay. And the next one is the firms are able to expand the scale of operation by purchasing larger quantity of all inputs. As I said earlier, in the long run there is only variable, actually all inputs are variable, so the firms are able to expand the scale of operation by purchasing large quantity of the inputs. You can purchase a larger quantity of raw material, you can purchase larger you can employ various employee, more number of employees, etc. Okay, and another thing is that in the long run, all factors are variable because all inputs are variable. You can increase or we can increase the size of all the all the inputs. So in the long run, all factors are variable. And next one, actually in the variable in the long run, we are discussing the cost output relationship mainly between the total cost and the output, that is TC and Q. Okay, and in the long run, cost output relationship is influenced by the law of returns to scale we already studied in the third module. And when going into the detail, we can see that in long run, a firm can move from one plant to another, as I said earlier, and regarding the size of production, regarding the regarding the quantity of output that we need, we can move from one plant to another. If you need smaller quantity, you can choose a smaller plant. If you want a medium quality, medium quantity, not quality, quantity, you can choose a medium plant. And if you want larger quantity, you can choose a larger plant. So a firm can move from one plant to another. Next one, the firm can acquire larger plant if you want to increase the output and smaller plant if you want to reduce the output. Next thing, it's very important. For each plant size or scale of production, the firm has a separate short-run average cost curve. So, for example, if we are using three types of plant, that is small plant, medium plant, and a larger plant, for each plant there will be a short-run average cost curve. Okay, so for each plant size or scale of production, the firm has a short-run average cost curve. And long-run average cost curve means it is the composition or it is the summation of all these the series of short-run average cost curve. So long-term cost average cost curve composed of a series of short-run average cost curve. In the last example, we had seen three plans and each plan have short-run average cost curve. So for finding the long-term average cost curve, what we need is uh, mm, it's the composition of the series of short-run average cost curve. Okay, and next we are going to see the derivation of long-run average cost. As we said, it is a summation of short-run average cost curve. First thing, in the long-run average cost curve composed of series of short-run average costs depend on the possible size of the plant. So based on the possible size of the plant, it will have a short-run average cost curve. And to find out the long-run average cost curve of that particular firm, it is the composition of series of short-run average cost. In the figure below, we can see three short-run average cost curve. That is this one, first one, SAC1, that is short-run average cost curve of first plant, and SAC2, that is short-run average cost curve of second plant, and SAC3, that is the short-run average cost curve of third plant. Okay. Again, SAC1, it is the average cost curve of short-run average cost curve of small plant, and SAC2 of medium plant, SAC3 of larger plant. Okay. Next graph, we can see that two axes, that is x-axis and y-axis, average cost is depicted in the y-axis and output is depicted in the x-axis. Up to the OP units of output, small plant is profitable because average cost is very low. And the average cost up to the production of OP is PB. Okay, because in the y-axis the average cost is depicted, so up to the production of OP the average cost is PB, and the production below OP, that is the production be below OP means production up to OM. It can also be produced with a small plant and medium plant. Here see SAC1 and also SAC2 is also passing through the OM output. Okay, so we can say that the production below the OP up to the OM, it can also be produced with the small plant and the medium plant. But if we produces with a small plant, that is we are producing with the OM with a small plant, the AC will be, that is the average cost will be MA. Okay, once again I'm repeating, if we produces OM units of output with a small plant, the average cost will be MA. Again, if we are using the medium plant to produce the output or this particular output, OP output, the AC will be ML. Okay, the AC will be ML. Once again, I am repeating this point. If we are producing with a small plant up to the OM, the average cost will be MA. And the same output, if we are producing with the medium plant, the average cost will be ML. Okay, so we have two average costs, that is MA and ML. Comparing the MA and comparing the ML, we can conclude that up to the production of OM or up to the production of OP, the small plant is preferable because MA is less than ML. So always we are preferring the reduced average cost. So we are producing OM or OP up to the production of OM and OP. we are using the small plant. Okay. Again, production between the units OP and OR, the production between the OP units and the OR units, the small, or sorry, the medium plant is more profitable. The reason is that the AC is only QC. Okay, so we are preferring the medium size plant uh, to produce the output between the OP units and OR unit. And the same can be operated with the small firm. That is the production between OP units and OR units can also be operated with a small firm. But what the problem is the average cost will be QK. Okay, the average cost will be QK. So compared to QC and compared to QK, we can conclude that the medium size plant is more profitable because QC is less than QK. Okay, so for the production between the OP units and OR units, the medium sized plant is more profitable because or due to the reduced average cost. Okay, and next is again for the production beyond QR. For the production beyond QR, the larger size plant is better because due to the reduced cost per unit. As said earlier, there is a series of SAC curves in the long run. We had seen that SAC1, SAC2 and SAC3. And the long run cost curve, we will get the long term cost curve by drawing a line that is tangent to all short term cost curves. Okay, so the long run average cost is tangent to all the short run cost curve, that is SAC1, SAC2 and SAC3. Okay, long-term average cost envelops all the short-term cost curve. It touches all the short-term cost curve. So it is also known as envelope curve. As we see in the case of small, medium, and larger plants, LSE curve helps in the determination of appropriate plant size. So we have seen the case of OI, case of the production of OP units. We have two options, that is smaller plant and the medium plant. But we seen that for the production of output up to the units of OP, the smaller plant is preferred because the AC is very low. So LSE curve helps in the determination of appropriate plant size. And the long-run average cost is also known as the planning curve. So we have seen two different names for long-run average cost curve. That is, first one is it is the envelope curve, and the second one is it is the planning curve. Why the LAC is known as envelope curve? Because it envelopes all short-run curves. Why the LLC is known as planning curve? Because it helps in the determination of appropriate plant size. And the next topic is long-term marginal cost curve. Long-term marginal cost curve. In the last class, we discussed about the short-run marginal cost curve, and you know what you mean by the marginal cost. And here we can see that Lmc curve represents the cost of producing additional output when all the inputs vary. It is the cost of producing an additional output when all the inputs are variable. Like the long-term average cost curve, LMC is also derived from the various short-run marginal curves. And it is actually this the LMC curve can also be it is the also it is the summation of various SMC curves. And short run average cost and long run average cost are equal at the point where LAC curve is tangent to SAC curve. See the points of P, Q and R in the figure. See, SAC and LAC are equal at the point P, and also the SAC and LAC are equal at the point Q, and in the R also the same, that is the SAC and LAC are equal at the R, at the point R. Okay, so that is another finding, and we see that as above, SMC and LMC is equal corresponding to the above points. So corresponding to the P, we can see the C where SMC1 and LMC are equal. Okay, and in the Q, actually the SAC and LAC are equal at the Q. Again, SMC and SMC2 and LMC is equal at the Q, and in the T we can see that SAC, SMC3 and LMC is equal in the point T. Okay. So in this in the figure we can see two things, that is the SAC and LAC are equal at some points, and corresponding to the SAC and LAC points, equal points, the SMC and LMC is also equal. How we get the LMC, that is a long-term marginal cost curve? How we can draw the LMC curve? As we said earlier, it is a summation of various SMC. So LMC here, it is a summation of SMC1, SMC2 and SMC3. So if we draw a line that is tangent to these three SMCs, we will get the long-term marginal cost curve. Okay, so LMC is obtained by drawing a curve connecting the points of S, Q and T. We know the peculiarity of S, Q and T. Here the SMC and LMC are equal. And LMC curve, again, look into the Lmc curve and Lac curve, that is the long-term marginal cost curve and long-term average cost curve. We can see that Lmc curve intersects Lac curve at its lowest point. Last session also we discussed about the least cost input combinations, and we have seen the conditions for input combination, that is all should be equal, SMC equal to SAC equal to LAC equal to LMC, and we seen that in the last slide also we have seen that LMC curve intersects LAC curve at its lowest point, and that point is the ON is the optimum output level, because the 2 points, that is LMC and the LAC, intersects at the Q. So ON is the optimum output level, and for producing the ON units of output, the cost will be NQ. Okay, is it clear? So we can say that the Lmc curve and the LAC curve intersected at the point Q. It is the point, it is the lowest point, and we can see that for produce ON is the optimum output, and for producing the ON output, the cost will be the NQ. Okay, and the firm which achieves the above level is known as optimum firm. So the firm which achieves this particular level, that is the Q, in the Q in this figure, that is known as the optimum firm. Okay, and we already discussed the concept of optimum firm both in the short run and the long run. Once again, we are repeating the same. The general features for the optimums, for what are the general conditions for finding the optimum firm, we can see that a firm reaches the optimum level of production where the average cost curve is equal to MC. In the last figure, we had seen in the Q point, that is the LAC equal to LMC. So the first general condition is that for a firm wants to reaches the optimal level of the production, either AC should be equal to the MC. So the first condition is AC should be equal to MC. And the next condition is that a firm reaches the optimum level of production. It is the point where the AC equal to MC. And the next point is the maximum productivity or the maximum efficiency point of this firm. That is, it is that point where the AC is equal to MC. It is that on that point there is another peculiarity, that is, it is the maximum productivity or maximum efficiency point of the firm. So if the questions should be like this, which point is the maximum productivity or maximum efficiency point of the firm? So the answer is that it is that point where the AC is equal to MC. Because why we are saying that it is the point of maximum productivity, or it is the point of maximum efficiency, because the cost of production per unit will be lowest at this point. Okay. And the optimum, don't be confused that the optimum level is not the maximum profit level. It is not the maximum profit level. A firm reaches it the maximum profit when MC is equal to marginal cost is equal to MR. Okay, so for finding the optimum level, for finding the maximum productivity, the condition is that AC is equal to MC, and for finding the maximum profit, the condition is MC is equal to MR. Okay, so for the general condition for the finding the optimum firm is a firm reaches the optimal level of production when the AC is equal to MC. Okay, that's all. Thank you. Please see this video and raise your questions if any in the comment box. And there will be a test paper for this particular module number 4. I will announce it later. Anyway, thank you. Be positive and stay negative to COVID-19. Stay home and stay safe. Thank you.